Today I'm going to talk about LeetCode question number 994, rotten oranges. Given an n by n grid where each cell can have one of three values, 0 representing an empty cell, 1 representing a fresh orange, or 2 representing rotten orange. Every minute, any fresh orange that is forward directionally adjacent, so up, down, left, right, not diagonal, to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If that's impossible, return -1. Okay, so we see in this example here, we have a rotten orange here, and then when minute 1 passes, these two become rotten, and then when minute 2 passes, whatever orange is adjacent to these two, they become rotten. So, and then minute 3, this guy has no adjacent fresh oranges, this guy has one adjacent fresh orange, so in minute 3 this becomes rotten, and then minute 4 the last one becomes rotten there. Okay, so how do we determine which oranges will become rotten? Okay, which oranges are next to a rotten orange and will become rotten the next minute? Okay, so you might be initially thinking maybe we could do DFS, depth first search. It's a strategy where if we want it, to explore adjacent cells of one cell, then we can do that with DFS. So, for example, here, and then with one round of DFS, these become rotten, and another round of DFS. One of these oranges become rotten, etc. But then the problem is with DFS is what if two oranges were rotten at the same time in the beginning? Okay, DFS can't really do two at a time here. Okay, because otherwise, if we do DFS, it'll say, okay, in minute 1, these oranges become rotten. I'll do a different color. So in minute 1, these oranges become rotten. Then minute 2, these oranges become rotten. And then minute 3, these oranges become rotten. Or, yeah, DFS will say minute 1, these oranges will become rotten. Okay. Minute 2, these oranges become rotten. And minute 3, this orange becomes rotten. So that's what DFS will say. But this is not correct because according to the problem statement, actually, so DFS says it'll take 3 minutes. But really, these three oranges are becoming infected, or these 4 oranges are becoming infected at the same time, okay? Because this guy is adjacent to this guy is adjacent to this, and then lastly this one becoming infected at the same time. So really it should take 2 minutes, not 3. DFS is not really good for in case we have multiple rotten oranges and they need to infect at the same time. So what can we do instead of DFS? Well, we can do BFS. So BFS. And how that's going to work is BFS, it will store all the rotten oranges at the same time. So in this case, if you have this example here, where this orange is rotten and this orange is initially rotten. So initially the array will look like 0, 0, and then 0, 2, 1. Okay, representing these 2 rotten oranges. And then through every iteration of BFS, we see which fresh oranges these rotten oranges will rot, and then store them in a new array here. So this, and this. Okay, so I won't write all those positions down here, but okay, 4 oranges will become rotten. And then the next iteration, it'll look at this array, and from these positions, it'll determine, okay, which fresh oranges are forward directionally adjacent to these rotten oranges, and then collect that information. Okay. And yeah, that's how we're going to basically go about it. We're going to use breadth first search. Okay, so the runtime would be O of M by N. Okay, so now to code this up. So first off, what I want to define is my number of rows in the grid and number of columns, just to make it easier. Okay, and then I'll define my BFS function. Okay, so initially what this BFS will do, and then I'll have my Q here for BFS. So initially what my BFS function will do is go through the entire routing, the entire grid, and store the positions of the rotten oranges in the queue. Okay. What I also want to do is count how many fresh oranges there are. Okay. And why do I want to do that? So let's say there's a grid where let's say the rotten orange is up here and the fresh orange is down here. In that case, it will be impossible to turn this orange rotten. Okay. As we're going to the queue, every time we make an orange rotten, we're going to decrement the fresh orange counter. And if at the very end there's a fresh orange remaining, then that means it's impossible to turn all the oranges rotten. So we'll return -1. Okay. So now fresh count equals 0. So for I in range row length, for j in range column length, if grid at I and j is equal to 2, that means it's rotten orange, then q dot append, store the positions of I and j here. And if grid at this position is equal to 1, then increment fresh count. Okay, that looks good. Now for the main body of our BFS, so while the length of Q does not equal 0 and fresh count is greater than 0. Okay, so we want to execute the BFS if one of these is true or both of these are true. Okay. Because if fresh count is greater than 0 but our queue is empty, then that means we have no rotten oranges. Okay, either that or it's impossible to reach a rotten orange or fresh orange. Okay, so while that, I'm gonna define my new queue here. Okay, and this new queue is gonna store all the fresh oranges that just recently turned rotten. So, and for positions in queue, I'm gonna have a row equal to position at index 0, column equal to position at index 1. Okay, now we're gonna search for directionally. So first we're gonna search up. Okay, so if row minus 1 is greater than or equal to 0 and grid at position row minus 1 and column is equal to 1, then simply we make this 2. And also what we do is decrement fresh count. And also what we do is store this newly rotten tomato in new queue. Append, so minus 1, column. Okay. Now the down direction. It's almost similar to this one. So if row plus 1 is less than row length, because if we're looking downwards, we want to make sure it's in the range of our grid here. And grid row plus 1 is that. Okay, easy enough. And then now let's look at the left direction. So if column minus 1 is greater than or equal to 0 and grid row column minus 1 is equal to a fresh orange, turn that fresh orange into a rotten one. Decrement fresh count, and then new queue dot append column minus 1. Okay, and then finally to the right. So call plus 1 is less than call length. Okay, and now after all this, we just collected the positions of the fresh oranges that just turned rotten, and then these oranges will be looked at in our next iteration of our breadth first search. And finally, after all that, minute, I suppose one, I realized I forgot to initialize my minute up here. Okay, and Q equals new Q. Okay, and now finally, once we're done with this whole breadth first search, how do we know when to return -1? So if fresh count does not equal 0, then that means it's impossible to turn all the fresh oranges rotten. So we return -1, and then finally just return minute. Okay. So outside of this function body, I'm just going to call BFS. And yeah, that should be it. Let me try compiling it. Okay, I'll use some of the example test cases here. Okay, I'll submit. Okay, great, thanks for watching.